We now discuss a problem from the section three-dimensional geometry. The problem is based on the concepts of line and plane in three-dimensional geometry. This problem has appeared in JEE Main examination held on 25th July 2021 in the morning shift. The problem is, let the foot of the perpendicular from the point P with coordinates 1, 2, -1 to the straight line L given by x by 1 is equal to y by 0 is equal to z by -1 be n. Let a line be drawn from P parallel to the plane x plus y plus 2z is equal to 0, which meets L at the point Q. If alpha is the acute angle between the lines Pn and PQ, then cos alpha is equal to, the four options are given to us. Let's now discuss the problem. We have a straight line L, x by 1 is equal to y by 0 is equal to z by -1. It is the equation of a straight line in three dimensions. This line L passes through 0, 0, 0, that is the origin, with direction ratios 1, 0, -1. And we are given a point P with coordinates 1, 2, -1. Let's look at the demonstration. This is the line L, and we have a point P, 1, 2, -1 are the coordinates of the point P. Given n is the foot of the perpendicular from P to L. From P to L, there is a perpendicular drawn that perpendicular meets the line L at n. So this is the point n. We have a plane x plus y plus 2z is equal to 0. Let's look at that. This is the plane x plus y plus 2z is equal to 0, and the direction ratios of the normal to this plane are 1, 1, 2. A line is drawn from P parallel to the plane x plus y plus 2z is equal to 0, and it meets L at the point Q. So, a line is drawn from P parallel to this plane and it meets L at Q. So, this is the line parallel to that plane, and that meets the line L at Q. Given alpha is the acute angle between Pn and PQ. So this is the angle. So that is alpha. So that is the alpha is the acute angle between the lines Pn and PQ. What's the problem? The problem is required to find cos alpha, cosine of the angle, acute angle alpha. Let's now discuss the solution in detail. And that is the given data, what we have represented in this diagram. Now, we have a straight line L and a point P. Now, this any point on this line L will be given by x by 1 is equal to y by 0 is equal to z by -1 is equal to lambda. Then x is equal to lambda, y is equal to 0, z is equal to minus lambda. That is lambda comma 0 comma minus lambda will represent the coordinates of any point on the line L. As lambda is varying, it will give rise to various points on the line L. Any point on L has coordinates lambda comma 0 minus lambda, that point. Now because n lies on the L, n will also have coordinates of this form, lambda 0 minus lambda. Let n be with coordinates lambda comma 0 comma minus lambda. Now the direction ratios of P, n. The coordinates of P are known. The coordinates of n, lambda 0 minus lambda, are known. So the direction ratios are lambda minus 1, 0 minus 2, minus lambda minus 1. That is lambda minus 1, minus 2, minus lambda plus 1 are the direction ratios of this Pn. And now this Pn is perpendicular, orthogonal to the line L. And the line L has direction ratios 1, 0, minus 1. And the direction ratios of Pn are known, the direction ratios of L are known, and Pn is orthogonal to L will imply lambda minus 1 times 1 plus minus 2 times 0 plus minus lambda plus 1 times minus 1 is equal to 0. So this is the one. Now simplifying, we get lambda is equal to 1. Take this lambda is equal to 1 and substitute in the coordinates of n. Then it will be 1, 0, minus 1. So therefore, the coordinates of the point n are 1, comma 0, comma minus 1. That we will show in the next diagram in the next slide. So the diagram is here, and we have the point n with the coordinates 1, 0, minus 1, which is given here. Now let's proceed. Let Q be the point with the coordinates mu, comma 0, comma minus mu. And this is same as lambda 0 minus lambda for a different lambda. And that we have taken as mu. As mu is varying, and it will give rise to various points on Q. So let the coordinates of Q be mu, comma 0, comma minus mu. And the direction ratios of PQ are mu minus 1, 0 minus 2, minus mu minus 1. That will be mu minus 1, comma minus 2, comma minus mu plus 1 are the direction ratios of PQ. Now, the direction ratios of the normal to this plane are 1, 1, 2. So, the direction ratios of the normal n, it's not the unit normal to the plane are given by 1, 1, 2. So, what's the normal? This is the normal. Now, this normal and PQ are orthogonal. Now, PQ and n are orthogonal. Therefore, the sum of the product of their direction ratios will be 0. So, that will be equal to mu minus 1 into 1 plus minus 2 times 1 plus minus mu plus 1 times 2 will be 0. And simplifying, we will get mu is equal to minus 1. Then the coordinates of Q will be minus 1, 0, plus 1. So therefore, Q will have the coordinates minus 1, 0, 1. So the coordinates are given here, minus 1, 0, 1. Now, we know The coordinates of n we know, the coordinates of p we know, the coordinates of q we know, and the angle is given as alpha. We can now calculate cos alpha using vectors or otherwise. And what we see is p and q, they lie in the same plane. Therefore, this is a right-angled triangle. So cos alpha will be equal to the length of Pn by the length of the hypotenuse, that is PQ. So cos alpha will be equal to length of Pn by length of PQ is equal to, length means the distance between 1, 0, minus 1 to, or 1, 2, minus 1 to 1, 0, minus 1. That is 1 minus 1 whole square under the square root of 2 minus 0 whole square plus minus 1 plus 1 whole square. That is this one. And the distance, the length will be 1 minus 1 plus 1 whole square under the square root of 2 minus 0 whole square minus 1 minus 1 whole square. This is what we have written. And simplifying, we will get the numerator is 2 and the denominator is under the square root of 12. That is equal to 2 by 2 root 3. 2 cancels and it is 1 by root 3. You can also calculate cos alpha using that formula, cos alpha formula, using the vectors, and we will get this same answer. And let's look at the options. And the 4 options are given here, and our answer 1 by root 3 appears against the option 1. Therefore, our answer is option 1, that is, the answer is 1 by root 3. So that is the detailed discussion of the solution of the problem from the 3-dimensional geometry related to a given line and a plane and the required angle alpha, and we have found cos alpha as wanted. I hope that you have understood the solution of this problem and go on working out some more problems from 3-dimensional geometry. And I wish you all the best. Thank you.